Hello, I am Cycle Lau. Today I'm going to present you about our IT infrastructure, which is about the hospital. And firstly, I would like to introduce our hospital, which is Highway Medical Center. Highway Medical Center is a major, which has 400 bed hospital in Malaysia with 1,500 staff in high-risk area like the ICU. Our IT system isn't just a tool, it's a lifeline to provide top-tier care. Our technology must be just as strong, but staying ready 24/7 leads us to how we actually operate. Specifically, our digital operation, we are 100% digital hospital, meaning doctor need instant access to record to save life. From check-in to the pharmacy, every step depends on the network. Even a small glitch can stop our work and put patient at risk. However, being fully digital has created some big challenges. The problem that we face is the challenges that we can no longer ignore is our old services. Old services are a major risk, and our huge MRI scan and running out of storage space. We also face constant threat from hacker and must follow Malaysia PDPA privacy law. To solve this, we have set one clear goal for our new design, and the goal is 99% uptime. We are moving to cluster service, so if one fails, another take over instantly with new high-speed storage. Our system will be safe, legal, and always ready to save life. This is the overview of our Highway Medical Center. So right now I'm going to present about hardware system and storage infrastructure. To start my part on hardware, I want to give you a quick technical overview. Managing a 400-bed hospital is a huge task, so we have invested 12 million ringgit to make sure our system are top tier. As you can see on the screen, our hardware is built for 4 pillars: our computer, our network, our storage, and our data highway. Our main goal for all these equipment is 99% high availability, which basically means the system is always on when a life is on the line. But to keep it on, we first need the right computer to do the heavy lifting. For this, computer and client hardware, which bring us to our compute and client hardware. We don't just use standard PC, we use enterprise services specifically designed for database and medical imaging. These services use ABAS or special high-speed connector to talk to our data instantly. On the clinical side, we use tablet PC. These let our doctor and nurse stay mobile across the 400-bed campus while still having full access to patient record. Of course, those tables ain't useful unless they have a strong, reliable connection, and that where our network hardware come in. The heart of our networks is Ally Telesis switchblade. We use a technology called VC Stack Plus, which is just a fancy way to saying we have removed any single point of failure. If one part breaks, the other wireless point running. This hardware keep our tablet connected everywhere using VLAN to keep medical data private. Now that we have a path for the data, let's talk about where the data actually live. Specifically, our storage media, we use different type of hardware for different need. For fast data, like hard monitor, we use NVMe SSDs because they are incredibly quick. For old data or archive, we use LTO tape to stay compliant with PDPA 2010 law. To keep everything safe, we use RAID write SIG. This is the safety feature that lets the system keep working even if two physical hard drives fail at the exact same time. However, moving those huge fly between moving those huge file between the disk and the server require a dedication fast lane. And finally, uh, the fast lane is our fabric channel SAN. Think of this as a dedicated highway for data that support speed up to 32 Gbps. By using this separate hardware, we achieve traffic isolation. This means a huge MRI and CT scan won't slow down the internet for the rest of the hospital. We secure that through zoning, which act like a digital gatekeeper, and with redundant controller, we ensure the storage never stops. These complete a hardware setup that is reliable, secure, and ready for the future. That's all for my part.
Greetings, sir. My name is Abu Bakr. Student ID is 25038296. So today I'll be presenting the infrastructure and identity management strategy for highway hospital. In a medical environment, system failure isn't just an inconvenience. It's a life and death situation. Our design focuses on three things: 24/7 availability, lighting fast access for doctors, and total data security. So first, let's look at the backbone of the system. We are moving away from the old separate servers to a hyper-converged infrastructure, HCI. This combines compute, storage, and networking into one unified platform. Why? Because it eliminates the delays doctors face when waiting for a critical scan to load. We have identified four key server roles. So, first one is the database servers, the brain of the hospital, running clustered SQL for the HIS and the AMR systems. The second one is application servers. These handle the logic for the pharmacy and lab separately to keep things fast. The third one is file and printer services. These are essential for thousands of reports generated daily. The fourth one is directory services, the gatekeepers that manage logins. So the next one is the Windows Server 2022 data center. We choose this because of its enterprise features like failover clustering, which moves virtual machines instantly if a physical server fails, ensuring zero downtime. We are targeting a 99.99% of uptime using a hybrid cloud approach, keeping medical data on site for speed while using the cloud for non-critical backups.
I'm going to talk about the network and security infrastructure of highway medical center. This is very important because hospitals need fast and secure network to handle patient data and daily operation. So I was explaining how the network is designed and how it protects sensitive information. And these are the device and components of a network. Then you know all the device. And the hospital use a three-layer network design. These layers are core, distribution, and access. The core layer is the main part of the network. It handles a large amount of data and ensures fast communication. The distribution layer acts like a middle layer. It controls and organizes how data moves through the network. The access layer is where all devices connect, such as computers, medical machines, and stat devices. Different topologies are used in each layer. For example, mesh topology is used in the core for reliability, tree topology in distribution for structure, and star topology in access for easy connection. This combination helps the network stay stable, flexible, and efficient. The hospital use different types of network depending on the distance. LAN is used inside the building for daily operation, which are also called local area network. MAN, metropolitan area network, is used to connect nearby buildings like the main and sub building. WAN is used to connect to clinics that are far away. This setup allows the hospital to communicate different locations. It also ensures that patient information can be shared quickly between needed. Here are the examples of mesh topology, tree topology, and star topology, as I mentioned before. The network infrastructure is divided into two main buildings. The main buildings focus on administration and IT system, and the sub building focus on the medical and emergency services. This separate improve performance and reliability. If one part has an issue, the other can still continue operating. High-speed call switches are used as the backbone of the network. They allow fast data transfer between departments. Also, hardware firewalls are placed at the network edge. These firewalls monitor all incoming and outgoing traffic to protect the system from cyber threats. VLAN segmentation to improve both security and performance, the network uses VLANs. VLANs divide the network into smaller groups. Each department has its own VLAN, such as emergency, patient administration, and pharmacy. This means that sensitive medical data is separated from general or guest traffic. It also reduces network congestion and improves efficiency. For example, emergency department data will not mix with guest Wi-Fi traffic. This is very important in a hospital where speed and accuracy are. For data stored in the system, ES256-bit encryption is used. They ensure that patient records are protected even if someone tries to access them illegally. For data being transmitted, TLS is used. This protects data from being intercepted during communication. The system also uses firewalls and access control lists. These two block an authorized user and allow only approved staff to access sensitive data. This helps and ensure that the hospital allows data protection regulations like PDPA. For the network design, and the network design is based on three important security principles, also known as CIA trait. First, confidentiality. This means only authorized staff can access patient information. Second, integrity. This ensures that the data is accurate and cannot be changed by the mistake or by the attackers. Third is availability. This means the system is always accessible when needed, especially during emergency, and that the network is always available for 24 hours. To support this, the network uses backup system and redundant call switches. This helps avoid downtime and ensure continuous operation. For the conclusion, the network and security infrastructure of the hospital is carefully designed to be fast, secure, and reliable. By using a layered network design, VLAN segmentation, encryption, and strong security controls, the hospital can protect patient data and maintain smooth operation. Thank you.
So, the next topic which we are going to see is the directory services and identity management. Now, how do we manage who gets into these systems? We are using the X500 standard for our directory. The biggest benefit here is the single sign-on, which when a surgeon logs in once and instantly gets access to the AMR lab results and imaging without needing 10 different passwords. Like that will be hassle free, right? So for communication, we use the uh, LDAP protocol. It's lightweight and runs over TCP/IP. So which means authentication happens in milliseconds, critical during a medical emergency, which will be really helpful. So we organize users through organizational units. For example, a radiology group can see MRI files, but someone in the billing department cannot. So that makes the hierarchy model more accurate in this case. So this is how we ensure the PDP-8 compliance here in Malaysia. And also we use the LDAPS to encrypt passwords and audit logins. So here we have a digital paper trial of every single file access. So even in the security and compliance, we use authentication and access control lists to maintain the organization very perfectly. So we have an implementation roadmap here, which first is the infrastructure, which basically is like a plan to implement this at the end. So after infrastructure, we have the directory. After directory, we have the security, and then the integration. So after all these, we will then plan to um, imply all this with their specific.
Good morning everyone, my name is Nikshya and I will be presenting part F and G covering the application architecture and ethics framework for highway medical center. Uh, well, we will cover 5 areas in part F: overview, middleware and web development, OLTP and the data warehouse. Then move into part G on ethics and standards. HMC serves over 10,000 patients a month across 3 campuses. To manage this, they run several core systems: EHR, HIS, LIS, RIS, pharmacy and billing. All of these are connected through a service-oriented architecture with enterprise service bus acting as the central communication layer between applications. The ESP runs on Camel and connects 35 applications and 12 external partners. Its key job translating between HL7v2 and FHIR, the modern healthcare data standards. IBM MQ handles messaging if a system is down, message up and retry automatically up to 3 times. The table show priorities. For example, red result to doctor are high priority. HMC uses a 3-tier architecture. Tier 1 is the DMZ, handles SSL and F5 big balance load. Tier 2 is the application layer. JBoss EAP runs inside Docker containers managed by OpenShift with zero downtime deployment. Tier 3 is the data access. A proxy SQL splits read and write queries offloading 60% of database load during reporting. HMC processes 95,000 transactions per day through 19C with ACID compliance, ensuring no partial updates. Critical for prescriptions, average response time is under 200 ms. For analytics, there are separate data warehouse using a star schema centered a patient encounter fact table every night. An ETL pipeline loads data. Power BI dashboards show KPIs like bed occupancy and waiting times. Now we will go part G, ethics, standards and professionalism. Part G address something often overlooked, the ethical responsibility behind every infrastructure decision. If HMC system fails, patient could receive wrong diagnosis. If data leaks, live are affected. IT here is a literally life critical. HMC4 ethical pillars are patient privacy, duty of care, informed consent, and equality of access. For example, RBSC ensure a nurse only see what relevant to their role, nothing more. Malaysia's PDPA a 2010 has 7 principles and HMC has implemented all of them. The most technical significant is the security principle AES 256. At the rest, TLS 1.3 in transit, IDS, IPS and MFA for all admin accounts. Record are retained for 7 years per MOH guidelines, then security deleted. HMC follower ISO IEC 27001 for information security management, HL7 FHIR for healthcare data exchange, and NST cybersecurity framework with covers identify, protect data, detect, respond, and recover. Our professionalism, all staff hold certification like security or CCNA, complete 40 CPD hours yearly, and a whistleblower policy lets anyone report unethical behavior safety. HMC has identified 5 key ethical risks: insider thieves migrated by RBSC, and monthly CISO log reviews on the EHR. By-year gapped backups and incident response plan by cyber insurance, shadow IT, blocked Viva application, vendor block lock-in prevented by mandating FHIR compliance, APIS contracts, and AI diagnosis basis. Reviewed by Ethical AI Review Board before any AI tool is deployed. To conclude, Part F shows how HMC middleware platform connects 35 applications with ESP and IBM MQ process 95,000 daily translations with ACID complaints and uses star Sechman data warehouse to drive management dashboards. Part G showed that this infrastructure is covered, ethical, fully PDPA compliant, aligned with ISO 27001 and NICT CSF, and backup by a protective ethical risk register. Highway Medical Center design puts a patient well-being and data integrity first. Thank you.